So I think I've started this video like 5, 6 times. So as you saw from the last video, long division and synthetic division can lead to a lot of mistakes. And you want to learn both quite well. Synthetic division's great when there's nothing in front of the x, when it's just 1. When it's 2, you're going to have to add an extra trick. And when it's x cubed or x squared, you're going to pretty much want to use long division. Just learn them both. I'm going to put up a link that explains why synthetic division works. And it's quite clear, but you're going to want to learn both. As you saw from the last video, long division produces more errors, in my opinion, but both can, so you got to be very careful. Now, long division is just like long division for any number. And the other thing you got to notice is when you're missing a term. So notice that there's no x squared in this one. So you have to add in an extra term right here, plus 0 x squared. And that's true for your divisor too. We'll just put that over more. There we go. So ask yourself now, what do I have to multiply x by to get x cubed? Well, x squared. If I multiply this times the x, I get x cubed. And if I multiply it times minus 4, I get minus 4x squared. And that's why we needed this 0x squared up there. Now I'm going to subtract it. These cancel out. But minus 4x squared makes a positive. Jeez. Makes a positive. I hate this marker. 4x squared. There we go. Sort of. Now you got to bring the minus 2x down. And what do I have to multiply x by to get positive 4x squared? Plus 4x. If I multiply times the x, I get 4x squared. And if I multiply times the 4, I get minus 16x. When I subtract it, it's always subtraction. These cancel out. And this becomes positive 16x, so I get 14x. Then I bring the last number down, plus 1. To get the 14x, I got to multiply by plus 14. I get 14x as I want, and I get minus 56. When I subtract it, minus 56 becomes positive 56. So my remainder is 57. So the book is going to want you to write it like this. The quotient is x squared plus 4x plus 14. And the remainder is 57. Boom. So notice the quotient's always up here, and the remainder is always down here. If your remainder is 0, it means that this is a perfect factor of that and is on the x-intercept. So you would find a spot 4, 0 on the x-intercept. The fact that we find 57 tells me that the spot we're actually going to find is 4, 57. I believe. I'm going to verify that, but let's see. X cubed minus 2x plus 1. X cubed f of x. Oh, my fingers are not working today. Is equal to x cubed minus 4x plus 1. Is that it? X cubed minus 2x plus 1. Okay, let's see if we can find f of 4 on here. And sure enough, look at that. F of 4 gives me a y, 57. So that's kind of how it works, is that f4 didn't give me a result of 0 because it's not on the x-axis. Instead, it's way up here at, oh no, I'm not at the right spot, way up here at 4, 57. Now, this is how you write it as a quotient, but if you're going to write it as a factor, you'd write it like this, or factored form. You'd write it like this. You'd bring back your original divisor. You'd put it in front of your original dividend. Or sorry, you put it in front of your quotient, and you'd add your remainder at the end like this. And you get rid of this 57 down here. So this is the correct factored form. If I write this into Desmos, I'll get the same graph as if I write this. And you'll realize that when you multiply this out, you actually get this original dividend right there. You can see it right here when you multiply plus 4x, you get plus 4x squared. And when you multiply the minus 4 times x squared, you get minus 4x squared. Those cancel out and explains why there's no x squared in the dividend. There's no x squared. You'll also realize that you can write it like this, or you can put the 57 in the bracket, like this. But if it's in the bracket, you have to write it like a fraction over the divisor, like that. This will be more important in calculus. You'll see the use of this more in calculus. But if I write this into it, I'll get the same as this graph, and I'll get the same as the graph I just wrote out. And you can see that when you do the last multiplication here. These cancel out, and I'm essentially just left with plus 57. That would be outside the bracket. Just important to know how to write it in factored form, what the things are, and what they're trying to teach you. All right, let's, for quick sake, I'm not going to do it for all of them, but just this one. I'm going to do this again, and remember to add the 0x squared plus 0x squared. But let's look at synthetic division. So for synthetic division, you have to take the root of this. What's the root of x minus 4? In other words, what x value makes that whole bracket 0? Plus 4. And what's the number in front of each of these? Well, the coefficient in front of the x cubed is 1. The coefficient in front of the 0x squared is 0. Coefficient in front of the minus 2x is minus 2. And finally, the 1. Then you do a bracket like that, and you start with your root. You start by bringing the 1 down, and that's going to be 1x squared. We'll just put the x squared yet. Now, I know it's going to be x squared because it's 1 less than that. So 1. What's 4 times 1? So I'll just put it there. 4 times 1 is 4. Goes here. In synthetic division, you add them. Let's add 0 and 4. I get plus 4. What's plus 4 times plus 4? It's plus 16. When I add them, I get plus 14. 4 times 4 is 56. And when I add 1 and 56, I get 57. There's my remainder. And then each of these terms is lowered by 1 exponent, so that I now know my factor, my quotient is 1x squared plus 14x, plus 4x plus 14 with a remainder of 57. So it's the same thing. Oh, wrong x squared goes right there. And notice the terms of my factor when my quotient is just 1x is simply 1 power less than each of the original terms. And that makes sense because when you divide anything by x, it's going to lower the power by 1. You can't make that assumption for other factors. But anyway, you can see synthetic division works quite well. It's very important that you pause and practice your long division and understand how to do it, because long division is useful for other things. In this one, we're not missing any terms. It's going to be a tricky quotient. So what do I have to multiply x by to get x cubed? X squared. And I get x cubed. And x squared times plus 2x is 2x squared plus 2x squared. When I subtract this, I get 0x squared. But it's important to have it there anyway. And I bring down the minus 6x. So how do I get 0x squared from x? I multiply it by plus 0. It's still important to put it in there. And I get 0 plus 0 when I multiply the 0 times both things. Now I subtract it, and I'm left with minus 6x. And I bring down that last number. And to get minus 6x from x, I have to multiply by minus 6. And when I multiply the minus 6 times here, I get minus 6x. And minus 12. When I subtract it, the minus 12 becomes 13. So that means my factors in this one, my quotient in this one, is x squared minus 6, and my remainder is plus 13. a couple things I want to point out. One, I want to make sure I got it right. So there it is there. Got it. You could also write it in factored form, as I said, with this in front. This now, instead of a quotient and remainder, becomes the full equation right there. If I were to expand this, I would get this equation right there. The other thing I want to point out, this has nothing to do with anything. It says, just as an aside, remember a difference of two squares, and it works when this is a perfect square? Well, you can actually figure out the difference of two squares even when the number isn't square rootable just by doing this. I just wanted to point this out. That means if I had this as a graph, the two roots, the two x-intercepts would be minus square root 6 comma 0 and plus square root 6 comma 0, which is roughly like 2.25, I think. What is the square root of 6? I won't be long on this. I just want to point out 2.44, which means if on a graph I just had f is equal to x squared minus 6, we will find those as the x-intercepts. There's minus 2.449 and plus 2.449. So you can actually do difference of squares even for numbers that don't square root to sort of understand your graph. That's just an aside. Let's continue with the long division. It's the same process over and over again. Notice this one has a 2x in front of it. 2x's will make things tricky. And actually, you know what? I'm going to do the synthetic division for this. Fortunately, all the terms are there. All the terms are there. We do our division box just to keep things orderly. Okay, I'm going to just bring it down. And I'm going to just go a little bit faster because you should be able to see what I'm doing here. 2x squared times, just 1x squared times 2x will give me 2x cubed. And times 1 will give me plus 1x squared, or plus x squared. When I subtract them, I get 4x squared here. I bring down this number. To get 2x into 4x squared, I have to multiply by positive 2x. When I expand that, I get 4x squared here. When I expand here, I get plus 2x here. When I subtract it now, this becomes minus 4x minus 2x. Becomes minus 6x. And when I bring down my last number, it's minus 5. To get a minus 6x from 2x, I have to multiply by minus 3. I get minus 6x, and the last one I get minus 3. And when I subtract it, this becomes plus 3, and I'm left with a remainder of minus 2. Which means my quotient, and I want you to remember this, is 1x squared plus 2x minus 3, and a remainder of minus 2. And don't forget to put the square there. Now just to make sure I got it right, we will see it right there. Got it right. Now I want you to show, I want to keep this way to show you the trickiness with long division. What's the root here that makes this, or with synthetic division, what's the root here that makes this whole bracket 0? Well, when you make it equal to 0, you discover that x is equal to minus 1/2. That's just simply the 1 goes negative 1/2. Then 1 goes the other side, negative 1, then you divide by 2. Negative 1/2 is the root. So that means we're going to try to fit negative 1/2 into what are the coefficients in front. We've got a 2, a 5, a minus 4, and a minus 5. And it's not a minus 2 here. It's just a 2 plus 2. Then we draw our sort of reverse long division. We bring the 2 down. When I multiply by minus 1/2, I get minus 1. When I add those, so 5 plus minus 1 becomes plus 4. When I multiply that by negative 1/2, I get negative 2. When I add that, I get negative 6. When I multiply by negative 1/2, I get plus 3. And when I add those, I get minus 2. Now I want you to notice that the minus 2 remainder is fine. But look at the terms. 2, 4, minus 6. Here I have 1, 2, and minus 3. They all got divided by 2, the number in front of x. And that has to do with complex factoring. Remember how you had to do factor by grouping whenever there's like a number in front of the x squared? Well, this here has created a complicated factoring system that sort of screws up the synthetic division process, but you can divide by 2. So if I divide all these numbers by 2, I get 1 plus 2 and minus 3, and those are indeed, this is not 0 here, those are indeed the factors that are in front over here. So you can see there's just a little extra tricky step that you have to do with synthetic division. And again, the link I send you will explain where synthetic division comes from. Now for these ones, it's actually a little bit more complicated. I'm just going to shut my door. Less than 5 seconds. So for these ones, you can see that there's an x squared in front, and it pretty much makes synthetic division impossible unless you can figure out another route to use. So synthetic division rather makes it impossible to do this. And you're going to have to notice now that this one is missing a term. It goes straight x squared straight to a number. So you should also add in, just to reduce your confusion, plus 0x. And that's because it's that missing term will make things extra complicated for you if you don't. Okay, and was it minus 7? No, it's plus 7. Good. So how does x squared become x to the 4? I multiply by x squared. When I multiply x squared by all these terms, I get x to the 4. And had I not put in the 0 there, I'd have all my terms screwed up here. And then this x squared times 7x times 7 makes 7 positive 7x squared. And because I added that 0, now my x squareds are lined up. When I subtract that, I get 0. I get 3x cubed, which is important to have. And when I subtract this, 7 minus 2 minus 7x, I get minus 9x squared. Now, believe it or not, you still have to bring the number down because there's 3 terms that are going to be created here. So I now have to bring down the plus 5x. So every time you do a subtraction, you have to bring a number down. So the next term that I create is plus 3x. The plus 3x times x squared will make 3x cubed. The plus 3x times 0 will make plus 0. Plus 3x times 7x will make 21x. And that's why bringing the 5x down was important. When I subtract them, I'm left with minus 9x squared. Minus 5x minus 21x is minus 16x. Then I bring the last number down, minus 1. And I simply multiply by minus 9. Get 9x minus 9x squared. I multiply times 0, so I get plus 0. And then the last one, minus 7 times 9, I get minus 56. Now when I subtract those, I'm left with minus 16x. This is my remainder. Minus 16x. And what's minus 1 minus 56? Sorry, minus 1 minus 56 is minus 1 plus 56, so I'm going to get plus 55. So that's my remainder. And what's my quotient? My quotient is up above, x squared plus 3x plus or minus 9. And then don't forget to put the x squared there. Let's make sure we got this right. There it is there. Oh, I got a plus 62, so I did an arithmetic error there. I do have the correct quotient, so I just got to check my arithmetic. So minus 9 makes minus 9x squared, got it, plus 0, got it. And then minus 9 times 7 is not 56. That's where I screwed up. It's minus 63. Basic arithmetic. So then when I subtract it, it becomes plus 62. Not plus 55. You guys probably caught that as I was doing it. So there you go. There's the quotient, and there's the remainder. I would not be able to do this with synthetic division, because it would be very difficult to figure out the root of that. Right? There's two roots. There's actually more roots. You'd have to use the quadratic equation to come up with the two roots, and then to do the synthetic division would be a nightmare. All right, moving on. This one's missing some terms. Notice how big the divisor is too. Okay. And what's missing? It's missing an x cubed. So you got to put in a plus. Let's just move it a bit to the left too. Got to put in a plus 0 x cubed. And make sure that your 6 actually has a minus in front of it. There we go, 3. Now you put up your division bar. Okay, this will have a huge remainder. So what do I have to multiply by? I have to multiply by x. And if I multiply by x, I get x to the 4 plus minus x cubed minus x squared. You can see where all the errors would come out here, plus x. And when I subtract that, I get plus x cubed I get minus 5x squared. And I get minus 9x. And then I got to bring down the number, plus 12. And when I do the last factor of that, it's just plus 1. So 1 times the x cubed, 1 times the x squared, 1 times the minus x, and 1 times 1. And then when I do subtraction, so this becomes minus minus, it becomes minus 4x squared. And this becomes minus minus, so it becomes minus 8x. And this one just simply becomes plus 11. Notice the remainder is bigger than the quotient. So I'm hoping my quotient will indeed x plus 1. And my remainder is minus 4x squared minus 8x plus 11. And hopefully I didn't make an error. And we'll see. So this is E. Looks like I got it. There's E. There's that with a giant remainder. And you might say, well, how does that graph? And it doesn't really graph. It simply means that since this is a really complicated divisor, you can't really find a point on it. This gets into more theoretical than concrete. Okay, and the last one, F. F will have a giant remainder. There's all terms no, we're missing terms on the left. We're missing terms in the dividend. So this is the divisor, and you can see we're missing terms in the dividend. We're missing quite a few terms actually. We're missing plus 0x cubed. And we're missing plus 0x squared. And you just kind of slide her back. And you can see how long it is now. Okay. Oof. Okay, we can pretty much get rid of these. Now, what do I have to multiply to get x to the 5? I have to multiply by x, and you can see that the factor is just going to be like x plus 4 or 3 or something. And then when I multiply it, I get x to the 5. So here's where all those arithmetic mistakes could be made. Plus x cubed. They fortunately made them all plus 1. Otherwise, it would be very hard to keep track of this. And then minus 2x. And when we subtract it, we get 3x to the 4 minus x cubed minus x squared minus 2x makes plus 11x. Now we bring our number down, plus 8. And our last one, you can see we're going to just have a giant remainder. Our last one is plus 3. So you get 3x to the 4 plus 3x cubed plus 3x squared plus 3x. And the last one, minus 6. When I subtract it, I get minus 4x cubed minus 4x squared plus 8x and plus 14. So you can see the remainder is huge, and the quotient is simply x plus 4. If I made an arithmetic error on this one, well, too bad. I'm not going to correct it. So let's see if we got it. So check, 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 plus 14, plus 14. Got it. Yikes. You can see how long division is. And you'll appreciate synthetics so long as you don't forget that one problem. So, synthetics a lot faster. What's the root? Plus 3. What are the coefficients in front of those things? Well, don't forget that you've got to add the missing x squared. So we're going to have a big old plus 0 here. Plus 0x squared. So that means the coefficients in front of it are 1 plus 0, if you want, minus 7, minus 6. And actually, I should never actually have a plus 0 plus in there, but just to help you realize that you're going to, that it's not negative or positive. So this is plus 3. Then you do your reversed long division. You start by lowering the 1. 3 times the 1 will give you 3. When I add them, I'm adding these. I get plus 3. 3 times this 3 gives you 9. You put it up here. When I add them, I'm getting plus 2. And 3 times the 2 will give me plus 6. And finally, when I add these, I get 0, which means that this indeed is a factor of that. And it's 1, 3, and 2. So I can write it down as the remainders are perfect. It's 1x squared plus 3x plus 2. And I'll just get rid of that. Replace it with a bracket. And don't forget my x squared. Now you might also ask yourself, can this be factored further? It's a parabola. It can. It's x plus 2, x plus 1. So we can see the full factors are x plus 3, x plus 1, and x plus 2, which means these will all have x-intercepts at minus 3 comma 0, minus 2 comma 0, and minus 1 comma 0. And if you were to graph this full one right here, you will discover these are the roots. And there's that one there. Oh, minus 3, sorry. So that will make that plus 3. And I'll just have to get rid of these. But these other roots are correct. Minus 3, which will make this one plus here. So it'll be plus 3, comma 0. So it's interesting to look further to see if this can be factored. But right now, that is indeed the quotient, and the remainder is 0. And if you go to your answers, that's what you'll find. There's the first one right there. And this, remember, is the factored form. This is the quotient. Okay, we'll go on to the next one. You can see how much faster synthetic division is, though. So long as you have all the terms in there. This one has all the terms. What's the root of this one? It's plus 1. So we're looking for plus 1. And if I bring down all the coefficients here, 2, minus 7, minus 7, plus 19. Then you simply do your reverse bar. Notice that this has just 1 in front of it, so we're fine. You start by bringing down the 2. 1 times 2 is positive 2. When I add these, I get minus 5. When I multiply by 1, I get minus 5. Goes up there. When I add these, I get minus 12. When I multiply by positive 1, I get minus 12. And when I add these, I get plus 7. So we can see this one has a remainder of plus 7. How can I tell that's a remainder, not part of the equation? Well, when x cubed, x squared, and x, which means these ones are going to be x squared, x, and there's a number. Well, you can't go further less x's than that. That's essentially x to the 0. Well, we can't go further than x to the 0 after that, so this has to be the remainder. It's a number. So anything after the number is the remainder. So that means my quotient is 2x squared minus 5x minus 12. And my remainder is 7. And if you look at the answers right here, that's what you'll find. Much faster. Synthetic division's much faster. Still no problems yet. First step, what's the root? Root's minus 3. What are the coefficients in front of this? 6, plus 13, minus 34, minus 47, plus 28. Do your reverse long division and start by bringing the 6 down. 6. Minus 3 times 6 is minus 18. You add these, you get minus 5. Minus 5 times minus 3 is plus 15. You add these, you get minus 19. Minus 3 times minus 19 is positive 57. When I add these, I get positive 10. Minus 3 times 10 is minus 30. Oh, close, but not quite. When I add these, I get minus 2. Which means that I'm talking about, since I had x to the 4, x to the 3, x squared, and x in a number, these are going to be x cubed, x squared, x, and my number. And that's why that's the remainder. So if I write it out properly, I get 6x cubed minus 5x squared minus 19x plus 10, and the remainder is minus 2. And if I put the proper numbers over them, that's what I get. And sure enough, if I bring this down, oh, it's saying no remainder on that. Oh, I got the wrong one. Hang on. It's this one. Did I get it? Looks like I did. Okay, you can see synthetic division has less chance of mistakes. Here's where the mistakes can happen. Right here. what's the root of this? The root of this is when that bracket equals 0. And then you solve for x. Well, I'll let you know right away. It's plus 3 over 2. That is the root. Now that 2, you're going to have to keep in mind when we're done. Plus 3 over 2 seems pretty weird. But let's start with the coefficients here. 2, 1, and they all have representation there. And plus 20. Then we do our kind of reverse long division brackets. We start by bringing the 2 down. When I multiply the 2 times plus 3, the 2 cancels out. Plus 3 over 2. The 2's cancel out. And it becomes 3. When I add these, I get 4. When I multiply 4 times this, the 2 goes into the 4, becomes a 2, and I get plus 6. When I add these, I get minus 16. When I multiply the minus 16 times 3, it gets divided by the 2, becomes minus 8. Minus 8 times the 3 is minus 24. When I add these, I get minus 4. So I can see that that's x squared, x cubed, x squared, x. So that's going to be x squared, x, and my number. So the quotient is 2x squared plus 4x minus 16 with a remainder of minus 4. Don't forget your squared. And if I look at this, sure enough, oh, look at that. Look what I forgot to do. So remember the 2 in front, that's the problem. You got to take all these remainders and divide them by 2. And thus, instead of this 2, it becomes 1. Instead of this 4, it becomes 2. And instead of this minus 18, it becomes minus 8. You have to divide them all by the number in front of 2. X, and it does not work if that's x squared. It only works if that's x. So you can see even I forgot, and there we get the right factors or the right quotient when I divide all those numbers by 2. And the remainder, which was minus 4, which looks like the remainder has to be divided by 2 as well. I question that though. Let's make sure that this becomes minus 8 times plus 3 is minus 24. When I add them, it does indeed become minus 4. So it looks like the remainder got divided by 2 as well, which that just makes me think I made a small error. So hang on. 3, let me just make sure I got the right remainders, that's for sure. So 2, then it becomes positive 3, then it becomes 4. 4 times this is positive 6, yep. It becomes 6. 6 times this, when I add those together, it becomes minus 16, which becomes minus 24. No, I got it right. Which has a remainder of 2. Let's see if I have to divide everything by 2 next time. Okay, so you can see the problem when there's a 2 in front. I still personally think if you remember that little trick with synthetic division, it's still worth doing synthetic division. But let's see if the remainder is true. So what is the root of this? It's negative 1/2. If you can't figure that out yet, you got to go back and revisit some stuff. So that's negative 1/2. What are my coefficients in front of each of these numbers? 12 minus 56 plus 59 plus 9 and minus 18. Okay, do my little reverse box and start by bringing the 12 down. When I multiply by my negative 1/2, I get negative 6. When I add these, it becomes negative 62. When I multiply that by negative 1/2, it becomes plus 32. When I add them, I get a 91. Here's where we're going to get problems. So that's minus 62 there, is it? Yeah. Plus 32. When I add them, I get 91. That's correct. When I multiply by negative 1/2 here, that's the problem. I get minus 45.5. Yikes. When I add these, I get minus 36.5, which is probably going to be expressed as minus 72 over 2. When I multiply these out, I get plus 74 over 4. I don't think plus 74 over 4 has a... Well, it might, actually. 2.5. So let me go back and do that again, because I think I made an arithmetic error somewhere. Should I bring this down? It's 12. Definitely 12 is the first root. Okay. When I multiply by that minus half, becomes minus 6. When I add these, it becomes minus 62. Okay. That's where I did my error right there. Minus 62 times the half becomes positive 31. Yeah, that's where I did my error. 31. When I add these, I get 90. When I multiply by minus a half, I get minus 45. When I add these, I get minus, oh geez, help me out, minus 36. When I multiply by half, I get plus 18. And when I add these, 0. So the 0 remainder tells me that this is indeed a perfect factor of that. I'll find this on the x-intercept. And it also means that but here's the trick. This started with a 2. So I have to divide all these by 2. So I get 6 minus 31 plus 45 and minus 18. Which means I'll write it out as 6x cubed, which is the one less than the original up above, minus 31x squared plus 45x and minus, I don't know why that keeps bugging me, minus 9. No, sorry. I had minus 36 there, right? So minus 18. Did I add those last ones right? Minus 70. Minus 45. Yeah, minus 36. So half of that is minus 18. And don't forget that this is cubed and this is squared. And sure enough, there it is there. Now, it might be possible to find other factors of this, and you could factor it perfectly, but right now this is the quotient with no remainder, which means that 2x plus 1 is indeed on the x-intercept. It is indeed a factor. And finally, this last one. It's a shame there's no remainder. I would have liked to have seen one with remainder. Okay, so when you figure out the root of this one, you're left with 5 over 2. And then when you bring down all these numbers, you got 6 minus 2. Oh, we got a problem. It's not in right order, so you got to put it in the right order. Minus 2 plus 5. They're trying to trick you on that one. Start by bringing down the 6. Multiplied by 5 over 2 becomes 15. When I add those, I get 0. When I multiply it, I get 0, which means that the x area will be empty. This is the x squared, because it's 1 less. So it's going to be 6x squared plus 0x. When I add these, I get minus 2, so that's going to be the number. When I multiply it, minus 2 cancel out with the 2, and I get minus 5. Plus 5 minus 5, 0. So that means it's going to be a factor of plus 6x squared minus 2. So there you go. And it has no remainder, which means this is a factor. And as I said before, what's interesting about this is technically you could figure out the two roots here because this is a difference of squares. It's just not a perfect square. So one of them is square root 6x plus square root 2. And the other is square root 6x, and the x is outside because the square root of x squared is x, minus square root of 2, which means the roots are minus square root of 2 over square root of 6 and plus square root of 2 over square root of 6, which I believe is the same as 1 over square root of 3. .577. Yeah. So you can always also cancel out here, and you get minus square root of 1, which is the same as 1, over square root of 3, and plus 1 over square root of 3. So if I were to take this original question, let's see, if I were to take this graph here, I would discover the roots are this 5 over 2 comma 0, 1 over square root of 3 comma 0, and it probably bounces twice over that, and 1 over square and negative 1 over square root 3 comma 0. It would be interesting to graph this here, 6x cubed minus, oh, we got to get it right here, minus 15x squared. Okay, so there's those two, 1 over square root of 3 and minus 1 over square root of 3. And there's the 5 over 2, which is also 2.5 comma 0. Interesting that you could figure out those roots using the difference of squares, even though it's not an easy difference of squares. And as soon as we discovered that this was indeed on the x-intercept because the remainder was 0, we could figure out those. Also, interestingly enough, I want you to remember that whenever you find a factor, if we plug 2.5 into this equation, it'll become 0. Here, look, let's see. And that's really important. That's the next chapter. It's called remainder theorem, which means you can test out various examples to see if you get 0 to figure out a root. Because if you get 0, you'll get a root. Well, you'll see more of that in the next chapter, but just keep that in mind that the remainder of 0 is very important. Each divisor was divided into another polynomial. All these are really hard and take a long time. I just want you to get used to going in different order. I might have to break this up into 3 parts because of all the chapters other than calculus, I'd say this is one of the longest chapters just because the process takes so long. So this case, I want you to remember what's a divisor, what's a quotient, what's a remainder, and what's a dividend. So each divisor was divided into a polynomial, resulting in a quotient and remainder. Find the other polynomial. So we know we took x plus 10, and we divided it into a mystery. We divided it into a mystery. But we got out of it, this is a quotient. So we got this up here, and we got this as a remainder. Well, this is where me pointing out the factors before, because the reverse of this, if I took this and divided it by that and got this minus 1, it would look like this. So let's just call this quotient, Q. So if I took Q and I'm dividing it by x plus 10, which is exactly what we're doing, and this book is telling me we're going to equal this quotient in brackets minus this remainder. How do I solve for Q? Well, you treat that like a little individual thing, and you get rid of it on this side by multiplying it by its reciprocal, which is x plus 10 over 1, on the left side, which will cancel it out. If you do whatever you do on the left side, you have to do on the right side. And actually, you have to write this as the official version that I mentioned before, that this one over here, just the remainder, is the same as minus 1 over x plus 10. Otherwise, it doesn't work out. So that to get rid of it on the right side, you have to also multiply it on the left side. Sorry, to get rid of it on the left side, you also have to multiply the same thing on the right side. And you can see what I was saying all along. You're actually getting it written like the factors. So simply stated, this quotient will be equal to the factor, the divisor, multiplied by the quotient, and the remainder. You just got to remember to write the remainder like that. And if I do it, let's do it. Now, I actually like the box method, as I've said many, many times. The box method is a fantastic way to do it. We've got x here and plus 10 here. And for my factors, or for my terms, I got this. So x squared plus 9. And this is an important one just to keep it clear in your head. Well, we'll get to that one. Probably just treat it as minus 1 at the end. Yeah, let's just treat that as minus 1 at the end. So if I'm going to multiply by x squared, let me just divide up my boxes here. We got 3. If I multiply my x times my x squared, I'm going to get x cubed. X squared times plus 10x is 10x squared. X times minus 6, I get minus 6x squared. Minus 6x times plus 10, I get minus 60x. Plus 9 times x, I get plus 9x. Plus 9 plus 10, I get plus 90. But remember that I'm going to have a remainder of minus 1. To get minus 1, I obviously have to have a minus 91 in here. And that might not be intuitive to you. So we'll get to that. Let's just leave it as 90. So let's write it out. Notice that these add together. I get 4x squared. And these add together. I get minus 51x. So I'm left with x cubed plus 4x squared minus 51x and a weird remainder plus 90. Squared x. But remember that I'm told that the actual remainder is minus 9. Or minus 1 rather. So that means to create this minus 1, I have to subtract a 91 out here. Let's see if this works. But I don't. I only have a minus 1 out here. So for that to work in here, my remainder would have to be, let's see what the answer says. I think that this would have to be for this to be minus 1. Well, no, maybe not. Let's see. Yeah, there we go. Plus 89. I was right. Oop. So if you look at this plus 90 and you subtract the 1, you get plus 89. And that's the only way it would work. So you take the box that we found and then you just subtract the remainder at the end. That makes sense. I could have included it as a divisible or multiplier, but I'd have to treat it as sort of one whole thing. Like if it's minus 1 over x minus 10, the x becomes minus x, and this becomes minus 10, then it becomes minus x over minus 10, and when you divide it all out, it becomes minus 1. So there's no real need to do it. You just include it as minus 1. So you can see that that is indeed the quotient that would exist. So really all that means is, all I have to do is take the divisor, sorry, not the dividend that exists. I take the divisor, multiply by the quotient, and then just add or subtract the remainder. So that means I can skip all the logic I just showed you and just constantly do my box like this. And just clear it out like that. And just put my, let's start fresh actually, and just take my divisors of my next one. There they are. Okay. Create a box that on the left side and the right side, and just put my terms like this. Here's my left. And here's my top. And I just got to remember to add 15 at the end. And then you just make a box like this. And you multiply each term like that, and you put it in the box. So I get 3x to the 4 minus 2x cubed plus 3x. Oh, notice that we're going to be missing some stuff. So it's not going to all add up the way plus 3x squared minus 2x and then we got minus 36. It'll still work. X. And then you got plus 24. So if I rewrite that, I get 3x to the 4 minus 2x cubed plus 3x squared. And then these last two add up. Minus 2x and minus 36x make 36x plus 24. But then I have to remember I'm going to add 15 from that remainder that I was told about. So that just becomes 24 plus 15, 39. And then when I put these over, I get 3, 2. Oh, actually I get 4, 3, and 2. And that's how the fastest way you can multiply two polynomials is this box method. There's other methods. YouTube it if you're interested. And let me just make sure I got the right answer and see how long these things take. We're up to this, right? So I'll just copy the whole thing. So it's this one. Got it. So it's easy when the thing that's missing is the dividend, because you just simply multiply the divisor times the quotient and add the remainder. The next questions coming up are far more frustrating. And you sort of got to do algebra within algebra to get it. Okay, next one is C. So we're just going to use the box method over and over again. We're going to take C. We're going to put it on two sides of the box. I'm going to make it a little bit bigger. And then we're going to take our quotient. We're going to separate it out a bit. And we're going to make a box. You can't forget a remainder is really weird here. So we're essentially going to add x minus 2, which is the same as adding x and subtracting 2 from whatever we get in this box. So that's the remainder. So you make a box to match your terms, and then you draw lines down the middle and dividing each of these terms up above. And then you just multiply this times that, and you put it in that box. So you get 5x to the 4, 2x cubed, plus 20x cubed. It's important to keep the signs there too, because these boxes will just add together. Plus 8x squared minus 25x squared. Notice the diagonal boxes are adding together because they're the same terms. Minus 10x plus 30x and then plus 8. So if I add these together, that's 22. That's minus 17. And that's plus, this was a 10. That's plus 20x. But don't forget, we're going to then have to add some here too. So we get 5. It's going to be a long one. 5x to the 4 plus 22x cubed minus 13x squared plus 20x plus 8. And then don't forget, we're also going to add an x right here. And we're going to subtract a 2. That's the remainder. If I put it over there, I'm going to get 4 to the power 4 to the power 3 to the power of 2. Which means when I add an x here, it's going to become 21x. And when I subtract 2 from that 8, it's going to be plus 6. And this should be the answer. This should be the quotient that got divided by x plus 2. Sorry, this should be the dividend that got divided by x plus 2 that created this quotient and this remainder. And let's see if we got it. Oh, I made a mistake on the numbers. With a remainder of, let me make sure I got x minus 2 as a remainder. X minus 2 it was. So I should be subtracting 2. Oh, here's the problem. Plus 6 times 2 is not plus 8, it's plus 12. So that's an arithmetic error. And then when I subtract 2, I get 10. That's how I got that answer, and that's why that one's wrong. Everything else is good. Whoa! Minus 13x squared. Oh yeah, that's an arithmetic error again. Minus 15x squared plus 8x squared is indeed minus 17x squared. And I even said it correctly the first time. I remember I said 17x squared. Everything else is right. But you can see as I get more tired, I'm making arithmetic errors. Always study when you're fresh and alert. So there's just one more. Use the same box method. This time the remainder's 3. Doesn't matter. The box method will work. I accidentally deleted the remainder somehow. Yeah. The remainder's huge. And that's okay. You still just treat it like adding something at the end. And I'm going to have to stop here. It's going to be a part 3 chapter. So we're going to just do this one. And it still works. Here's the answer there. You're going to take, this is the divisor, so you're going to put it down on the left side of your box. And this was your quotient. When you get confused about what's what, look up something simple. So say 12 divided by 3 has a 4 with a remainder of 0, which means 3 times the 4 would be 12. Makes sense, right? And 12 divided by the 4 would be 3, and 12 divided by the 3 would be 4. That's how all those things work. So if you can identify the dividend, the divisor, and the quotient, and the remainder, you can then go back and rework it for anything. Anyway, let's continue. This had a remainder, which I then this was the remainder. So at the end, I'm going to have to add this as a remainder. I botched the remainder. I put it in as the divisor. Oh no, I got the divisor. My bad. This is the remainder right here. So at the end, I'm going to have to add an x squared. I'm going to have to subtract an x. I'm going to have to add a 5. So let's put in our box, see if it still works, and I'll try not to do any arithmetic errors, but I will separate this out a bit more up top. It's a lot easier when it's all separated. And this is the last one I can do, and then I'll continue later. And then it also helps if you divide up the box. This might seem tedious, but this is one of the fastest ways to do polynomials. It's essentially what your teacher teaches you in class when he lines them up in order and then he adds them. This just visually makes it a little bit easier for kids who don't like the long process of distribution. So that times that makes 7x to the 5. And they usually add up diagonally as long as their terms all go down by 1. This one's missing x squared to x, so they won't go down by, it won't work out like that, but usually minus 2x to the 4. And then you just continue. X cubed times x squared, x to the 5, plus 7x to the 4. This was to the 4. So long as you don't get your coefficients wrong, it should work out. Minus 2x cubed minus 11x cubed. And then minus 77x squared. So you can see how confusing it would be if these weren't all separated in boxes. And then plus 4x squared plus 28x. Can't forget your dividend at the end either, but we'll do it at the end. Minus 8. Now, I'm going to circle to make it easy. Common terms. There's an x to the 5. There's an x to the 5. I don't see any other x to the 5s. In orange, there's an x to the 4. There's an x to the 4. I don't see any other x's to the 4. In red, there's an x to the 3. There's an x to the 3. I don't see any more x's to the 3. In blue, there's an x to the 2. There's an x to the 2. And finally, in purple, I guess, I got an x and an x. I'm not going to bother with the numbers, but I do have to remember that at some point, I'm going to have to add in that remainder. So let's add up all the x terms. I'm getting 1x to the 6. I see plus 8x to the 5. I see plus 5x to the 4. I see minus 13x to the 3. I see minus 73x squared. Oh, I got that wrong. 73x squared. 77. Oh yeah, I haven't subtracted or added my things yet. Yeah. I see in the boxes minus 73x squared. And then I see a plus 50x. And I have a minus 8. Now, in red, I'm going to put in right away my remainders. Oh, this is an x squared here. I can't forget that. And now I have to remember to add 1x squared. And I have to subtract 1x. So let's just do that right now. When I add 1x squared, I'm taking, these are from the remainders. I get 73. When I subtract 1x here, I get plus 49. And when I add 5 here, I get minus 3. So that should be the answer. Hopefully I got it right. Otherwise, it just makes me look like a fool. I think I did a subtraction on the x squared. I went the wrong way. Supposed to add it. Yeah, I think I subtracted. I went from 73 to 74. It should be going because this is minus, and I'm, oh no. Was it minus then? So was it 71, or did the book make a mistake? The book might have made a mistake there, because I don't think that's wrong. I think I went down the right way. Let's see if I still have it there. Minus 77 plus 4, and those are right, makes minus 73, and then when I subtract an x, it's minus 74. So the book made a mistake there. This is not right. That's minus 74. And I know because right there, that's correct. And I know this is correct. And I know minus 74x squared plus 4x squared is minus 73. And then the remainder, we're subtracting. Oh, no, you know what I did? Yeah, the x squared there, I should be subtracting an x. Yeah, so instead of adding an x squared, I subtracted the x squared because I saw minus x there. So the book is correct. That's a minus 72. That's because it is indeed minus 73 here, but I was supposed to add 1x squared to make it 72. And then everything else I got right. So there we go. There's the x to the 6. There's plus x to the 5. There's plus x, 5x to the 4. There's minus 13x cubed. This was the only arithmetic mistake I made, which is too bad. Then there's plus 49x and minus 3. So this works, just it doesn't help if you add in the wrong direction or get confused by the remainder. All I did was with the remainder was add it to each of the things that it belonged to, add it or subtract. So with the x squared, I had to add an x squared to the existing box x squared. With the minus x, I had to subtract one of the x's. And with the plus 5, I had to add plus 5 to this minus 8 to get minus 3. That's all you do with remainders. Okay, that's it for now. That's a long session.